Let's start with a quick warm-up. Do a little product rule and a little chain rule. Just to prime the pump, if you will. I'm not concerned about you simplifying it completely right now, but I am concerned about you being able to do the basic operation of product rule and quotient. If you want to multiply out the derivative, you can. You should normally, but since we're just using this as a warm, you don't necessarily have to. There's a- So let's see, you can eat this or something. Oh, stick it in your tray.
It says it on the box.
Trust the box from the manufacturer of the calculator. Let's see, if I wanted to sell a calculator, what would I put on the box to make sure to sell it? Usable on the AP test.
Well, if it's wrong,
Just by having it.
Exactly. Just put it in your pocket, you automatically get a pocket. You
The
don't even
real
have to
winners
use it.
use this
for
calculator.
emotional distress.
This calculator will make you rich and.
Bill Gates uses this guy.
Includes a program for panic. Use it to calculate.
He'll wipe your tears.
It'll do your taxes.
It's only like $20 more than the regular one. So I'm just
What's
like-
$20? That's nothing.
I'm just like, I might as well get it.
Sure. And again, remember when you're doing a quotient rule, simplify numerators, do not multiply out denominators. Are we doing okay? All right, beautiful. Any problems with those two? Good. What's the
I don't think I did it right.
which one? This one?
The first one,
This
yeah.
times 5
Yeah.
plus that times 3x squared minus 4x.
Yeah.
It's open.
It worked the first time.
Oh, I see. I see.
Thank you. Found your mistake?
Yeah.
What was it?
I didn't take the derivative of 5x minus 4.
You had the whole thing in there. Rookie mistake.
Yes.
All right, chain rule. This is the last big tool that we're going to use for finding derivatives. It allows us to do all kinds of things that we couldn't do previously. In particular, it allows us to take the derivative of functions within functions. And I think I say some of this in the slideshow. But we're going to use chain rule. We're going to talk about some algebra. We're going to use trig. And you should know the state capitals. Yes?
Yes.
Wyoming?
Cheyenne.
Okay. Cheyenne? How about Florida, Colin? Good job, Colin. Thank you.
I'm glad there's a lot of Collins.
It was Naples?
No, it's not happening.
No, it's not a Hess. How about
Naples, why Naples?
Colin? How about New York?
Is it Albuquerque?
No.
Arizona.
That's in Arizona. Or
New Mexico.
Oh, Albany.
Albany, yeah. Colin, how about
So up.
California?
Los Angeles?
No. Sacramento. Hey, Colin, how about Illinois?
Springfield.
You're good about
Alright, I'm trying to tell you San Francisco.
Now you don't think he did that intentionally.
No, I think he literally does San Francisco.
No, did you think it was San Francisco?
Interpret how you want it. I'll take that.
He's just gonna leave a gray area there. Beautiful. Okay, so, like it says up here, and like I already mentioned, we're gonna be taking the derivatives of composite functions. So in this little chart, on the left-hand side, I've got functions that we can deal with up until we get to the chain rule. So you know how to take the derivative of x squared plus 1, sine x, 3x plus 2, and x plus tangent of x. Okay, those are all fairly simple. However, if I end up putting those within another function, I get a composite function, a function within a function, and we have to use the chain rule. Okay, and I'm going to introduce the chain rule. I'll give you the rule. It really won't start to make sense until we start looking at some examples. On a side note, let's talk about this puppy. Danny, you understand the difference?
Yeah.
Explain it.
The tangent of x squared is the tangent of the quantity x squared, and then tan squared of x is tangent of x times tangent of x.
Right, so this is the same thing as tangent of x quantity squared. You all knew that, right?
Yeah.
Outstanding. Just wanted to make sure. Okay, so there's the chain rule. Let's talk about some important things here. They do some substitution in there, but I don't like to use u, but it is fun to use fu. I like this bottom one is really what you care about. So we have a function within a function. When you take the derivative of that function within a function, you take the derivative of the outside function first, then you chain on, which is what that's called, the derivative of the inside function. And again, this will make sense, hopefully, when we start looking at some examples here. Bring it up.
How many layers of functions can you do that with?
Tons.
Like, could you,
Think of it like an onion.
could you like,
Sorry, what about
What
about an ogre?
Is it an ogre?
Yes.
cakes?
Thanks for the shrink.
What's
You can take as many as you want. But if you take too many, it causes problems. So we'll talk about when to stop, because otherwise you just go crazy. And what happens is if you don't keep yourself under control, you just keep chaining every function until you get to 0, and every answer ends up 0, which would obviously be wrong. So I'll show you when to stop. Because you think about, like, if you take a quartic function to the 4th power, you take the derivative and then you chain on, you go to a third and then a second and then a first and then a constant and then 0, and all of a sudden answer is 0 because it's all going to be multiplied together, and that's not right. So at some point you got to rein yourself in so you don't go crazy, which we'll get there in a second. This is most important. As you look at these composite functions, you want to ask yourself a simple question: how many functions am I dealing with? And then you're going to chain on one less than the number of functions. Fairly simple, yes? If I have 3 functions, how many chains? 2. 2 functions, how many chains? 1, etc., etc. Okay? That's what's going to rein you in. Because otherwise you just keep chaining like a mad person and it starts the downhill slide. Everybody's out of control. Okay, so we'll start with this guy. As it says up there, Grace, how many functions? 2, perfect. What are they?
2x minus 3 to the 92nd and half prime.
No. This function here, You were correct, is made up of two functions. What are the two functions?
Oh, 2x minus 3.
Good.
And then 2x minus 3 to negative first.
Negative second.
Or negative second.
Right. So the negative second is one of the functions. Whatever that thing is, we're taking it to the negative second power of. And the 2x minus 3 is the other function. So two functions, how many chains? One. Okay, good. Now, to take the derivative of that, think about this as being an onion, and you're going to work your way from the outside of the onion inward. So what function is on the outside? The 2x minus 3 or the negative 2? Negative 2. So we're going to do that first. Some people get tripped up by the idea that there's this 2x minus 3, but think of it this way. What's the derivative of this box raised to the negative 2 power? Negative 2 box raised to the negative third? Negative first? Negative third?
Minus 1 to negative 3.
It's negative 3?
Yeah.
Oh, can't fool you guys. Negative 2, oh sorry, f prime of x is equal to negative 2 times 2x minus 3 raised to the negative third power. That's the first derivative. Now we chain. And when we chain on, we take the derivative of that next layer of the onion. So the next layer of the onion would be the 2x minus 3. And the derivative of 2x minus 3 is 2. That's a multiplication symbol, by the way. Okay. And we're done. And that's where you stop. Two functions, one chain. Done.
Wait, can you repeat how you did the second part?
Sure. You got the first part, right, without the
Yeah,
2 there?
I blinked and I missed it.
I understand. It happened quick. Then the chain is the derivative of the next function inside on the onion. So the next function inside is that. So that 2 came from the derivative of that.
Can you just leave it like that, or do you want us to like multiply it?
I would probably just do this for now. Part of the lesson later is how far we have to simplify that. We're going to worry about that later after we get this chain thing worked out. Okay so far?
Yeah.
Outstanding. Well, let's ramp it up a little bit.
So, like you said, since there's two functions, there'd be one chain, but you still take two derivatives to create the one chain?
Yes.
Okay.
Yeah, so the chaining on is the one that happens after the initial derivative. And you chain one less than the number of functions. Okay. Two functions there. Do you see them? Good. One of them is the x to the fourth plus 3x squared plus 2x plus 1. And the other one is to the fourth power. Which one's on the outside? Fourth power. H prime of x is equal to 4 times x to the fourth plus 3x squared plus 2x plus 1. You don't change that at all. Reduce the exponent by 1. Two functions, one chain. So now I chain on the derivative of that stuff inside. 4x cubed plus 6x plus 2. And no, you don't need to multiply that out. That's the idea behind the chain rules. Without the chain rule, you would have to multiply out that monster. X to the fourth plus 3x squared plus 2x plus 1 4 times. So you just stop there. Okay, so far so good?
Yeah.
Okay, are you sure before I'm, yeah, go ahead.
So I just want to like make sure, so this only works when it's two functions, like if you try to do this with like a normal, like one function, well, you can't do it.
Excellent question. So, suppose you try to do it with a normal function. What happens is when you take the derivative, or you chain on the derivative of that other function, you're going to get 1.
Okay.
So it just, it's like when you have x raised 1x to the first power. We just choose not to write the 1s because it's silly. Same thing is true here. You could use chain on the other one, but why would you? It's more of a train wreck than it's worth. Okay, I apologize ahead of time for that.
Let's do it.
I don't know if you want to be so gung-ho about that, Sparky. This is going to get ugly. All right, so first of all, recognize the fact that we have a product rule because we have one function times another function. We good on that? So how do I, forget about this function, how do I do a product rule?
First times the derivative, second plus second times derivative.
Perfect. I'm sure you all heard Nick. first times the derivative of the second plus the second times the derivative of the first. Okay. Now, when we do the derivatives, we end up having to do a chain rule there. So g prime of x is equal to the first times the derivative of the second. Okay, let's stop and digest that. Is that you? Never mind.
What do you do? Nothing. I know what he's talking.
I know what he's talking about.
Oh.
Alright.
Putting little wads of paper in your hair. Being back in third grade. Kelly.
Would there be something in front of the first parentheses?
No.
Why not? Because you're
Because I haven't taken, I got it, Grace, thanks. Because I haven't taken the derivative yet.
okay.
So this is the first times the derivative of the second.
Okay.
Big question, go ahead. I just have a simple question, where'd that 2 come from?
That was my
That's a chain rule.
Chain rule.
Okay.
Okay.
Sure.
So I wrote 2x plus 1 to the 1/3 power, brought the 1/3 down, reduced it by 1. There's 2 functions there, so I have one chain, took the derivative of the stuff inside. That's the first half of the product rule. Here comes the second half. Okay, we're good, right? I didn't change anything. Well, I did. I just wrote as 1/3, but we're okay with that, yes?
Yep.
Okay. Derivative of the first thing. Two functions, one chain. Okay, so I know I'm belaboring this point, but it's an important thing. This is an example of where you want to be careful with the number of chains, because imagine if you continue with this now. You would then get 24x, then you'd get 24, then you'd get 0, the whole thing equals 0, you screw it up, let's move on. Okay, so again, 2 functions, one chain. How we doing?
So then
We
you
have
do
to
this in
simplify
cycle
this.
quotient.
Wait, I got 2 people asking questions. No, you first.
So if it's like a function over a function, we do the chain rule within the quotient.
Yeah. Victoria, what was your question?
So, do we have to simplify this?
Ooh, excellent question. Hold on one second.
I was confused where the chain rule comes into play. I got the product rule, I don't know where to put the chain rule into. Is it just for the second part of it?
Yeah, because I only
Is
took the
this-
derivative of that guy.
Alright.
Okay. Now let's talk about simplifying. The simplifying is not my main focus, and I just want to touch on it a little bit to show you what we're going to eventually end up doing. Now I know where we're going, so I know what eventually we want to get. You probably don't realize that yet. But the problem with this answer is that thing right there, that plus sign. I don't want that plus sign there. Again, because of stuff we're going to do in the future. So I'm going to factor out common terms. You with me? So what do those 2 things have in common?
2.
Yes, we have a 2. What else? 4x cubed plus 3. We'll worry about the power in a second. And 2x plus 1. And then we've got a bunch of other gunk that's left behind, which I'll come back to. Now the question is, what power will be there? 3. The smaller of the 2 powers, 4 or 3, you got to take the smaller one. What power is here? Now this is an important rule. You always take the more negative value. So I want to factor out a negative 2/3. And I'll show you why in a second. But again, always take out the smaller or more negative power. Okay, so if I take this stuff out of the first term, I'm left with a 4x cubed plus 3 times a 1/3. That's out in front, that's out in front, the other 3 of those are out in front, so I'm done with that. Plus, let's do the easy part first. I took a 2 out, so that leaves a 2 behind, times a 12 is a 24, x squared. That whole thing went out in front, and I'm left with a 2x plus 1. To what power? If I have an x cubed and I factor out an x, what am I left with behind? How do you do that? What am I doing with the exponents? Subtracting. So I have a 1/3. I took out a negative 2/3
First power.
to the positive one. Right. And that's why we take out the more negative answer, because you will, I don't want to use the word always, but you will frequently get just the first power there. I'm going to stop there as far as simplifying. You would then go on to simplify that stuff in brackets. You're done simplifying the stuff there. And the reason, again, that we do that is because we want to have a series of products, not a bunch of addition and subtraction. Those don't pop up a lot, but they will. But this idea of factoring out a more negative exponent will become pretty commonplace in the problems that you're working with. Can I erase this? Okay, let's skip this. I want to go, yeah, so we'll come back to that if we have time. I actually wanted to look at this guy. Always have to incorporate a trig problem there. Connor, how many functions?
2,
No.
3.
3. What are they?
4x to the 5th.
Good?
Sine.
Good.
Of, and then sine. Again.
No. Well, kind of sine again, but. Does that help if I rewrite it?
So it's sine times 4x to the 5th and sine times 4x to the 5th.
Correct. What function is that you just described? The squaring function.
Yeah.
So 4x to the 5th, the sine, and then the square function. 3 functions, how many chains? 2. And what function's on the outside? It's easier to see now that I rewrote it. Squared function, right. So we're going to do that one first. F prime of x is equal to 2 times whatever this thing is that we're taking a derivative of, raised to the first power. So, okay, which function is the next layer of the onion? The sine, right. So now I take the derivative of the sine function, which would be cosine, of that thing, whatever it is, times the last chain, which is the derivative of that, 20x to the 4th. Okay, give that a second to sink in. Is everybody good with that? Go.
Why do you do the trig function first before the 4x to the 5th?
Because again, think of the layer. You're starting on the outside with the squared function. As you move inward, the next function you run into is the sine function. And then the sine of what? Of the 4x plus 5. Yeah, so I mean, that's another way that you could look at it is, what are we doing first? It's a squared function. What are we squaring? Sine. Sine of what? 4x, and then you work your way How much you clean this up right now, I'm not really that concerned about it, but you could probably do this 40x to the 4th times the sine of 4x to the 5th times the cosine of 4x to the 5th if you had more board to work with there. Okay. But again, we'll worry about simplifying later on. I'm more concerned that you're able to... Hey everybody, it's Mr. Mirandola.
Hi everyone.
Sorry, they're shell-shocked from the chain rule.
It's understandable. I'm just gonna install it. I'm like, I'm pretty jacked about this. I'm gonna come by and figure out how this has been missing from my life.
I understand. This is not something you want to be missing from your life. It's like getting hit in the head with a hammer.
Yeah.
It's like that commercial where the guy hits his head against like the cross beam because his hand's stuck in the.
Stuck in that, what is it, sleeping, camping in poison ivy, hitting your head in the cross beam, drinking spoiled milk, and
paper cut.
all paper cut in the lip.
Or tongue.
Good
Yeah.
stuff, yeah.
How many people would want a paper cut on their tongue?
I've managed to. That's happened before.
So a paper cut on your tongue, or what's the other one? It's the other one we can pull from there.
Sleeping in poison ivy?
Sleeping poison ivy. Which would you prefer?
Paper cut on the tongue.
Yeah.
Paper in
The
the
tongue
tongue.
one.
It's a small area and it goes away faster.
But you need to eat.
Yeah.
Paper cut to our tongue was like.
Drink
You're a
something
head
through a
boy,
straw.
See, sleeping in poison ivy would suck, but
I'm sure it's very soft.
No, the sleeping in the poison ivy wouldn't stop, it'd be the waking up.
Yeah.
So I'll take sleeping in the poison ivy, because I don't know.
Alright, so he's just gonna hang. Alright, so we'll worry about simplifying this later on. Occasionally what will happen is the answer key or the back of the book will do some weird trig stuff, so your answer might not match exactly, like there's a double angle theorem, and yeah, we don't care. I just want to make sure that you can work the function first before you are able to do that. Okay. Hey, that's what we got. Oh yeah, this is what I was talking about. So you might have this in the back of the book because they're going to do some sneaky trig thing. I don't care about the sneaky trig thing. Nor does the AP College Board care about the sneaky trig thing. Very seldomly will they expect you to know anything bizarre like the double angle formula of sine. Well, I'm sure you already all knew it, right?
So we don't do
Oh,
something.
yeah.
Totally have it on.
It's too easy. Why bother with it?
So wait, do we need to know this?
Well, you need to know everything, but I would not make this a major emphasis. Okay. All right. Before what time is this period over?
No idea. It's on my phone.
Yeah, it's on my
How do we get this schedule? How do
Yeah,
we
he's
get
got the schedule.
schedules?
Let's go back to this bad boy. We'll look at this real quick and I'll show you the last slide.
I think it ends at 34.
34? Okay, good. We got some time. So here's the original problem. We've got a quotient rule wrapped up inside a chain rule. So the previous example we did, we had chain rules wrapped up inside a product rule. This is doing the opposite. Function on the outside is the squared, so I brought the squared down, reduce it by 1, leave that puppy hanging out in front. Then do a quotient rule for that monster. And you get that mess. The rest of this is all simplifying, which at this point we don't really care about. Right? So another possibility there. The key at this point is recognizing how many functions you have and using that information to get the number of chains. Because otherwise, you're either not going to chain enough or you'll chain too many. Right? We good? All right, last slide I wanted to show you, which I think you'll be happy about, is the fact that we are done with derivatives. There are all the derivative tools we've used. Now, all we're going to do from this point on is practice this. Okay? So we got chain rule in there, product rule, quotient rule. We've got power rule, which makes our lives a little bit easier. What's not up there is the limit process. And so I've seen some of you on your homework doing the limit process when you don't need to. The only time you need to do the limit process is when it specifically says, use the limit process to find the derivative. They might. There are occasionally instances on the 8th test where they talk about the formal definition of derivative, which is the same thing as the limit process.
That was the last question I did.